So on the right triangle word problems, I call it a hack because if you see these words, you can automatically know which side of the triangle we're going to be talking about. So I believe we will start with the left side, that vertical. So the first blank, it'll always be the height of something, height or altitude. So you're going to fill that in on that triangle. So we're going to start with the vertical side. Your first blank will be height. So if it said a tree is 700 feet tall, which is ridiculously tall, that would be that side. Okay? So the height is the number one thing I see. A pole, a flagpole, a tent pole, literally anything like that is going to be vertical because poles are supposed to be that way. In geometry and in trigonometry, we always assume that it will make a right angle with the ground because that's the correct way to install it. So we just assume that. So just so you know. A wall, the same idea. We assume it's a right angle with the ground. It'll always be that vertical side. Usually it's the height of the wall. Another is a tree. Usually it'll tell you the height of a tree, something to that effect. And then the top of a blank. This is actually the hardest one for most people. It'll say the top of a slide, the top of a building, the top of a tree, to the top of a balcony, something to that effect. Because when we're talking about the top of something, that's actually referencing height. So if I wanted to measure to the top of my whiteboard, you would measure from the ground all the way to the top of the whiteboard. So that's why it's that side. But this is the hardest one, I think, for people to remember. So if you want to put a star next to it, anytime you see top. All right. The next one, the length of a box. The length of a box. I'm going to draw you a rectangle in yellow. A triangle, and in particular a right triangle. So here's a rectangle. Here's all the right angles. A triangle, a right triangle, is half of a rectangle. So if it said the length of a rectangular box, that would be this side. And then we'll talk about the width as well. Okay, so now we're going to talk about the bottom. The most common horizontal side will be the ground. So whenever you're drawing and you're hopefully picturing this in your head, buildings sit on the ground, slides are on the ground, trees are on the ground, all that. The distance from a building, a pole, a base, this is the hardest one for people. But you're looking for that keyword from. It'll say like 10 feet from blah, blah, blah. If we were measuring from me to my cabinet, you would measure the absolute distance, and usually the best way to do that is using the ground. A shadow, which you see on the ground. I've never seen a shadow in the air, not really. You've seen it on on like a wall or something. But whenever you see the word shadow, it's usually on the ground, like 99.9% of the time. At least in trigonometry, it's going to be on the ground. And then the last is the width of a box, for the same reason I showed you earlier. All right, so that's your vertical, that's your horizontal. The last one is the hypotenuse. So the hypotenuse it's a leaning side, right? It's not upright, it's not flat. So anything that is leaning or diagonal, that's the first thing. Anything that is leaning or diagonal will be your hypotenuse. Leaning or diagonal. What's the hypotenuse in this picture? The ramp. A ramp is a hypotenuse. And in this picture, you can see this would be like the height of a stage, or to the top of the stage. You might see that word. And then the base of the ramp to the base of the stage, that would be your horizontal. And then, of course, your ramp is the hypotenuse. All right, and in this one, a ladder. Ladders usually lean 99.9% of the time. That's the way they work. So a ladder is a very common one. Anytime you see a ladder, it is leaning. Even if it doesn't say it, I have never had a trigonometry problem where it went straight up a wall. It's usually leaning. So a ladder. And then a rope or a wire hanging from a pole. A rope or a wire hanging from a pole. Do you know why they have wires hanging from poles? I used to show it. I don't anymore. It's for stability. Just for stability. It keeps the pole up even when it gets windy. It'll stay upright. Yeah. So you might see a wire. Flagpoles are less often shown, but like a guy wire is used in gardening, and it is used to like keep the pole upright. So it would look, like this. Yeah. Right. A diagonal of a box or a field. There's a problem somewhere someday that I'll talk about a soccer field and the diagonal, like running diagonally across a soccer field. So that would be your hypotenuse, because the hypotenuse is diagonal. And then last, anytime it says north and south, that would be like vertical, because that's what north and south is. Anytime it says east and west, that will be horizontal, because that's where east and west are, or west and east, however you want to say it. And where they meet is always a right angle. We kind of talked about that before in 9.1. But where north, south, east, west meet, they make a right angle. And then I think that brings us to using this. So I would not put it away. I would put it beside you. We're going to use it to draw pictures in a word problem. I always recommend drawing pictures first, and then we can go from there. So this one, we have Zoe. Swims 14 kilometers west and then 9 kilometers south. How far is she from her starting point? So we want everything to end up looking like a right triangle. So you can already have a right triangle drawn, or you can be particular for the west and the south. Depends on what you want to do. It just depends. Which one do you want? Do you want the same uniform triangle every time? I've heard yes and a no. We'll do both. If we did 14 kilometers west on this triangle, which of the sides would be the west? The flat side. So this is 14 kilometers. I don't know why I wrote west, but there we are. And then 9 kilometers south would be the vertical. If you wanted to be 100% accurate, she swam west, which is to the left. Then she swam south, which is down. But if you notice, either way, you get the same idea. We want to know how far she is from her starting point. So is that a side or an angle? A side. It's the third side. So either way we did it, we would have gotten the same idea. We're going to use the Pythagorean Theorem, because we have two sides, and we need to find a third. So which of these is missing, A, B, or C? C. So 9 squared plus 14 squared. Usually it asks to round to the tenths, so we'll just do that unless it says otherwise. You can type in 9 squared and 14 squared all together. What is 9 squared plus 14 squared? What is it? You're all talking very quietly. 277 equals c squared. Take the square root. So like I said, we're just going to do the tenth unless otherwise told. So what is that? 16.6, and we can say kilometers. Kilometers. Which is a lot. Don't ask me how much, but it's a lot. Number 2. Oh, not even number 2. We're going to talk about angle of elevation and angle of depression. So we've seen it before in problems, but the problem was always drawn for us. So we'll go back to our picture really quick. You have a line drawn here, right? It's dotted, isn't it? Okay. So we can talk about angle of depression first. Angle of depression, when you think of depression, you think of like down, if you had to think of a direction. It is always on the outside of the triangle, angled downward. So this is what we call the angle of depression. Go ahead and label that on your triangle there. Angle of depression. So we're back on the paper from before. Angle of depression. It will never be this top angle. It's always on the outside. Because an angle of depression always has a horizontal baseline and then goes downward from the horizontal. So that's angle of depression. Angle of elevation, again, it always has a horizontal base and opens upward. So this would be your angle of elevation. And then I'll actually point something out to you that will make this a little easier. So there's your angle of depression, your angle of elevation. These are 2 horizontal lines, right? What do we know about horizontal lines? They're what? We have a transversal. Yeah, we have 2 parallel lines and a line touching both of them. So that's a transversal. So what are we going to know about this angle and this angle? They're going to be congruent. Yeah. So anytime you see angle of depression or angle of elevation, usually you can just label them both the same thing. Not usually. You can label them both the same. So just for you to know, we'll use it in this problem here. But this is, again, just showing angle of elevation using your eyesight, because that's the horizontal, like, baseline. Angle of elevation opens upward towards an object, and an angle of elevation opens downward towards an object. So just remember, elevation goes up, and then depression goes down. All right, and this is another way to see it. Is it on your paper also? Might be at the end. So this one is angle of depression, this is angle of elevation, and they're going to end up being the same measure. It's okay if it's not there. Okay. That's all I was going to say about it. We're just going to use it because I think there's an angle here. You are measuring the height of a lamppost. You stand 40 inches from the base of the lamppost. You measure the angle of elevation from the ground to the top of the lamppost to be 70. Find the height h of the lamppost to the nearest inch. So we're going to have a right triangle, right? Use words. If I were drawing this, what is my vertical side? I don't want a number, I want a word. What is it? The height of the lamppost. So I'm going to call it the lamppost right now. Lamppost. Looks weird to have 2 P's like that, but here we are. You're measuring the height of the lamppost. You stand 40 inches from the base of the lamppost. So the key word there is from the base. So which side is that going to be? On the bottom, the horizontal there. So 40 inches. Essentially, you are standing here. And then, there's our lamppost. You measure the angle of elevation from the ground to the top of the lamppost to be 70. So 70 is an angle. Yours might say degrees. Mine does not. But the angle of elevation goes here. This is just me showing you what it is. This would be 70 degrees. And we want to find the height of the lamppost to the nearest inch. To the nearest inch. So we're finding the height of the lamppost. Can I use the Pythagorean Theorem? No, because I have an angle. I have to use a trig ratio. So from 70 degrees, from my angle of elevation, what kind of side is the height? Opposite. And what kind of side is 40 inches? So which trig ratio will we use? Tangent. From 70 equals the opposite, which you can call whatever letter you want. It says height h. You can call it h if you want. If that's confusing, you can call it x. It really doesn't matter. We're only solving for one thing. And then over 40. Do I need to flip this one? Nope. Multiply times 40 So what do we get for the height of the lamppost? Or to the nearest inch? 110 inches. So to the nearest inch will be a whole number. All right, number 3. So the top of a slide is 12 feet from the ground and has an angle of depression of 53 degrees. What is the height of the slide? So again, we know we're dealing with a right triangle. The top of the slide is 12 feet from the ground. So is that my horizontal, vertical, or diagonal? It's the vertical. It is 12 feet from the ground. That's a height. It has an angle of depression of 53 degrees. So the top of the slide is the subject there, not to get into English really quick, but the top of the slide is the subject. It has an angle of depression of 53 degrees. So from the top, it has an angle of depression of 53 degrees. But anytime you're given the angle of depression, you can go ahead and label the angle of elevation the same, because they're going to be congruent. Then it says, what is the length of the slide? So, now let's envision. This is the top of the slide. Sorry, it's in blue. This is the top of the slide, right? Okay. So which of these, we want a length. Which of these is the length of the slide? Is it going to be the horizontal or the diagonal? The diagonal. This is going to be your slide. So we can call that X if you want. That is the length of the slide that we're trying to find. So we have an angle, and we have a side, and we want to find another side. So what are we going to use? Trig ratio. From 53 degrees, what kind of side is 12? Opposite. And then the slide would be the hypotenuse. So we're going to use sine from 53 equals the opposite, which is 12, over the hypotenuse. You can call it whatever you want. I called it X on mine. This one, we do have to flip. X is on the bottom. We need it on the top. And then multiply times 12. So remember, it's the length of the hypotenuse. It should be longer than 12 feet. So what do we get? 15? Did we round? Okay. It rounded up 15 feet. It didn't say, so that's fine. Usually it will say.
It said 15.02.
0.02. Okay, so either way. Perfect. How are we feeling about it? Good. The angle of elevation of a ladder leaning against a wall is 70. The base of the ladder is 1.4 meters from the base of the wall. Find the length of the ladder to the nearest tenth of a meter. So again, we're going to have a right triangle. The angle of elevation of a ladder leaning is 70. So angle of elevation goes down here. And this is a ladder leaning. So if you want to go ahead and label, this is where your ladder is. The base of the ladder is 1.4 meters from the base of the wall. So where am I going to put 1.4? On the bottom. Because the base of the ladder, which is on the bottom, is 1.4 meters from the base of the wall. We're going to find the length of the ladder to the nearest tenth. All right, so again, an angle and a side. We're going to use a trig ratio. What kind of side is 1.4? Adjacent, and then the ladder, hypotenuse. So we're going to use cosine from 70 equals the adjacent, which is 1.4, over the hypotenuse. We again will have to flip. And then multiply by 1.4. The ladder is longer than 1.4. So if you get smaller than 1.4, then I would check it. And we're doing to the nearest tenth, like it says. So what do we get? 4.1 meters. I know that doesn't sound like much, but 1 meter is about 3 feet. It's like 3 feet and change. So it's essentially 12 plus feet long, which is a good size ladder. Questions about our ladder? Okay. They're going to start getting harder. You buy an isosceles style tent with equal sides of 6 feet. So we're going to pause. This picture is going to look different because we have an isosceles style tent. What does isosceles mean to me? 2 congruent sides. So here's what it will, it kind of look like. 2 congruent sides. This is what a tent looks like, usually, right? With equal sides of 6 feet. So label your 2 equal sides, 2 congruent sides of 6 feet. The base of the tent is 10 feet long. So the base of the tent is 10 feet. Find all the angles. So this is not a right triangle yet. An isosceles triangle can be broken up into a right triangle. If you think of a tent, what is the structure of a tent? What holds it up? Sticks, like poles. So essentially what you're going to do is draw where that center pole would be, and it would be in the center because each of the sides are 6 feet. And it would be perpendicular with the ground. So is everyone envisioning a tent? This is like where you would walk in, let's just say that's the zipper to get into the tent. So find all the angles. So essentially it creates 2 congruent triangles. So if you deal with one, then you can kind of work with the other. So we have 6 feet. What is the length of this bottom portion? 5 feet. Okay, so I'll move the 10 feet a little further. That'd be 5 and 5. So we're going to find some angles. This angle will be the same measure as this angle. Okay, and then once we know 2 angles in a triangle, you can very easily find the top angle by adding and subtracting. So our goal is to first find this angle. So whenever we find an angle, we cannot use the Pythagorean Theorem. We're going to use a trig ratio. So we're going to figure out which one. From this angle, what kind of side is 5? Adjacent. And what kind of side is 6? So which trig ratio will we use? Cosine. From an angle we don't know, you can call it whatever you want. You can call it x if you want. Equals the adjacent, which is 5, over the hypotenuse, which is 6. We're solving for an angle, so what do we have to type in? We have to shift. Use the inverse. So then, what did we get? It doesn't say to round. 33? 33.5? 0.56, so it'd be 0.6. We'll do that. So that means this angle is 33.6. This angle is also 33.6. So to find the top angle, we can add them and subtract from 180. So let's go ahead and add them. What is 33.6 plus 33.6? Or you can double it, essentially. $67.2, good. And then we're going to subtract that from 180 to find the third angle. $112.8? Okay. Oop. Degrees. I do believe you see something like this again. I think the numbers will change, but it is the same idea. You'll draw an isosceles triangle and then draw a center pole so that you can make 2 right triangles. Is there a question on this one? Beautiful. You're skiing on a mountain with an altitude of 1,600 feet. The angle of depression is 32 degrees. Find the distance you ski down the mountain. So, you have an altitude of 1,600 feet. What is another word for altitude? a height. So which of my sides is going to be 1600? The vertical. Then it has an angle of depression of 32 degrees. So remember, an angle of depression is at the top of the triangle pointing downward, 32 degrees. You can automatically label the elevation also as 32 degrees. And then find the distance you ski down the mountain. So I want you to envision what skiing looks like. Do you ski on horizontal slopes or like downhill slopes? Downhill. So we're trying to find the height of this, or the length of your mountain slope. So we're going to use a trig ratio because we have an angle and a side. What kind of side is 1600? Opposite. And then our question mark, hypotenuse. So we're going to use sine. From 32 equals the opposite, 1600, over the hypotenuse. So we have to flip it. We are almost done. We're stopping at 7. Multiply times 1600. If we are getting the hypotenuse, should be longer than 1600. So what did we get? It doesn't say what to round to. Let's just 3019. Okay. Oop, that's not a. Yep. 3019 feet. Which is like a half mile, isn't it? Isn't a mile 5,280? So it's like half. Cool, cool. We're going to do one more, and then we'll be done. A fire truck extends a 105-foot ladder against a 56-foot tall house. What is the angle between the ladder and the ground? So a 105-foot ladder, where is my ladder going to go? Diagonal. Against a 56-foot tall house. So vertical. And then what is the angle? So we're finding an angle. What is the angle between the ladder and the ground? So that's going to be your angle of elevation. So we're finding an angle. We're given two sides. We're going to use a trig ratio. Which one are we going to use? Sine. I called it x. It doesn't really matter what you call it. But opposite is 56 over the hypotenuse, 105. When you're solving for an angle, make sure you always hit the shift button. What do we get? 32 degrees. Might we'll end there. Yeah, we'll pause there.